In this video, I'm going to continue with the linear programming problems. I've already talked about I've already given the notes of the linear programming problems, and we will be continuing with that. And particularly, I will be talking about the linear programming problems, the graphical solution. Well, if you have studied the notes, you would be able to know that the graphical solution to the linear programming problems is applied when we have two variables under consideration. Now, assuming that you have learned the theory behind the linear programming problems and proceeding directly to the graphical solution, I will just write a question and try to solve it. So I have a question like maximize the profits when the which is equal to 40x1 plus 35x2. Now over here x1 and x2 are the two products. When I sell this equation means that when I sell x1 I am able to earn 40 rupees on one product, and when I sell x2 I'm able to earn 35 on this product. So selling x1 and x2 I have to maximize the profits, the overall profits of the firm. Therefore my objective is to maximize the profits, and therefore this function is called as an objective function. Now when I have to produce x1 and x2, I'll be subjected to some constraints. Say for example, this x1 and x2 needs labor to produce, and for every 1 unit of x1 I require 2 units of labor, and to produce x2 I require 3 units of labor. But this labor is not available in abundance. This labor is available up to a limited quantity of, say for example, 60 units. And producing x1 and x2 also requires raw materials, and to produce x1 I require 4 units of raw material, and to produce x2 I require 3 units of raw material. But this raw material is available up to a maximum of 96. So these two equations become my constraint equations. Overall, the set of objective function and the constraint function is known as the structure of linear programming problems. So I have to produce two products, x1 and x2. If I sell x1 I will earn 40, if I sell x2 I will earn 35. And in a similar manner, for producing x1 I require 2 units of labor, and for producing x2 I require 3 units of labor. In a similar way, for producing x1 require 4 units of raw material, and to produce x2 I require 3 units of raw material. But this labor is available up to a maximum of 60, and the raw material is available up to a maximum of 96. So we will apply the graphical solution to it, given that there are two variables. Another thing that is a non-negativity condition that you can see into your notes. Non-negativity condition means that x1 and x2 cannot be negative. So x1 and x2 has to be greater than or equal to 0, which is a very important factor and very logical as well, because we cannot have a negative labor, we cannot have like negative raw material. In a similar manner, we cannot have a negative product. So x1 and x2 being greater than equal to 0 is logical, and therefore we need to apply this non-negativity condition. The step one to solve this by the graphical method is to first bring set of constraints into equality. So let me bring this equation first into equality. So this is 2x1 plus 3x2 is equal to 60. In a similar manner, let me call this an equation 1. In a similar manner, I have another equation, 4x1 plus 3x2 equal to 96. Let me call this an equation number 2. Now from this I will derive the values of x1 and x2. So if I put x1 equal to 0. So if I plug in over 0, then I have to divide 60 by 3, which is going to be equal to 20. Now if I plug in 0 over here, then this is going to be 0. I have to divide 60 by 2. This is going to be 30. In a similar manner over here, I will get the values of x1 and x2. Now if I plug in 0 over here, so I have to divide 96 by 3, which is going to be 32. If I plug in 0 over here, then I have to divide 96 by 4, which is going to be 24. So I have got these factors. Now let me move on and let me plot a graph for it. So I know that the maximum value for x1 and x1 is 30, and the maximum value for x2 is 32. So on x1 I need maximum up to 30, and on x2 I need maximum up to 32. So let us make a graph. Now let us say this is my x1 and this is my x2. I need 30 points maximum from this side. So this is my 0. So let's say this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then 30. From this side, let me say this is 4, this is 8, then 12, then 16, 20, 24, 28, 32, and then 36. Now when x1, now going back, now when x1 was equal to 0, x2 was how much? When x1 was equal to 0 in equation number 1, x2 was 20. So I will plot a point over here. When x1 was 0, x2 was 20. When x2 is equal to 0, my x1 was 30. So the another point is over here. So in equation 1, one point is this and another point is this. This point I got when x1 was 0 and x2 was 20. In a similar way, when x2 was 0 and x1 was 30. So I have 2 points and I need to connect them. So this is going to be my equation 1. That is 2x1 plus 3x2 is equal to 60. Now second equation, when x1 is 0, x2 is equal to 32. So the point is over here. Now when x2 is equal to 0, x1 is 24. Now this point over here. Okay, let me change the color for you, and now let us join these 2 points, 32 and 24. So this is my equation number 2, and equation number 2 is 4x1 plus 3x2 is equal to 96. Now the next step is that I need to find the feasible region. For that I need to go back into the constraints function, and I am going to write it for you over here. So I have 2x1 plus 3x2 less than or equal to 60, and I had another one, 4x1 plus 3x2 less than or equal to 96. So equation 1 says that it's a less than type, so I have to go left. I have to look at the less than type from the equation 1. Equation 1 is this, and I'm looking at the less than area, which is over here. And equation 2 also less than area. The less than area is this, and from both the less than areas, the common less than area will be this. Now why not this? Because this is only less than equation 1. Why not this? Because it's only less than equation 2. The only area that is less than both equations is over here. So I am going to mark the points for it. Let me call this as A. Let me call this point as B. Let me call this point as C, and let me call this point as D. Now the next step is that I need to find the coordinates of A, B, C and D. Now coordinates, for coordinates what I will do, simply I will look at the location of the points and then draw its coordinates. That's very simple. Now let us write down the coordinates. I'm going to write it over here only. Coordinates of A first. Mind it, when you write the coordinates, you have to first write x1, then write x2. So coordinates are to be written like this. First the value of x1, then the value of x2. So at point A, what's x1? 0. What's x2? 0. So coordinate of x1 for point A is 0 and 0. Now the coordinates for point B over here. So x1 is how much? 0. x2 is 20. x1 is 0, x2 is 20. Now for C, I cannot find it, I need to solve it, but I can find D. For coordinates of D, my x2 is 0 but my x1 is 21 because it's lying on x1. So this is 24 and this is 0. Now I need to find the coordinates of this C. For this I need to solve equation 1 and equation 2 because it is the intersection between equation 1 and equation 2. Therefore, for coordinates of C, what I am going to do, I am going to solve the equation 1 and equation 2. Now what is my, I am going to solve it by the elimination method. So equation 1 is like this: 2x1 plus 3x2, it is equal to 60, and this is 4x1 plus 3x2, it is equal to 96. So I am going to cut it. So this is going to be minus 2x1, it is going to be minus 96, so it's going to be 36. So if I cut them up, x1 is going to be 36 by 2, which is going to be equal to 18. So I can plug in 18 over here. So this is going to be 2 into 18 plus 3x2, which is equal to 60. So overall I'm going to get 36 plus 3x2 is equal to 60. So you can solve for x2, it is going to be equal to 8. So the coordinates of C are equal to x1 is 18 and x2 is 8. So I got coordinates of A, B, C and D. Now I can find a solution. So I'm going to write it and then I'm going to find a solution for you. Okay, now let us move on and find the solution. Okay, so simply I have 4 points A, B, C and D, and among these 4 points is the maximum profit. So let me write down the points first. I have A, B, C and D. So I have two values, x1 and I will be having the value of x2. So value of x1 is 0 and 0. At point B is 0 and 20. At point C it is 18 and 8. And at point D it is 24 and 0. Now what I will do, I will write an objective function over here, that is a profit function, 40x1 plus 35x2. Now let me solve it. For profit at point A will be equal to 40 into 0 plus 35 into 0, which is very logical because I'm not selling anything. I'm not selling anything of x1, not selling anything of x2, so profit is 0. At point B, I'm not selling anything of x1, but I am selling 20 units of x2. So my profit is equal to 700. At point C, I am selling 18 units of x1 and I am selling 8 units of x2. My profit is equal to 1000. At point D, I am selling 24 units of x1, but I'm not selling anything of x2, so my profit is equal to 960. Among them all, the maximum profit is 1000, which means that I can maximize my profits when I sell 18 units of x1 and I sell 8 units of x2. So the solution to this problem is that I have to sell 18 units of x1 and 8 units of x2. Now This is the way how would you can do the graphical problems. For the other problems, you can look at the notes that have already been given to you, and you can do rest of the examples from the book that we are consulting, and we'll be looking forward to do the simplex method.